Alright, in this video we're going to look at a few more properties of parabolas. So in the last video I kind of discussed different characteristics about the graph and the definition of a parabola. Now we're going to kind of look more at the equations when working with parabolas. So kind of the most basic equation for a parabola is y equals ax squared, where a is equal to 1 over 4 times p. Now this p comes from kind of the definition of a parabola, and it's this distance from our vertex of the parabola to the focus, and likely it's the distance from the vertex also to the directrix. So P will always be this length between vertex and focus and vertex and directrix. Now, this equation, A equals 1 over 4P, this is highly important. This will be used a lot in these sections when writing equations of parabolas. So we'll need to remember that A equals 1 over 4 times P. Now, I kind of want to go into a little bit more detail about where does A equals 1 over 4P, where does this equation come from? And it kind of comes from two things. One, the definition of a parabola, and two, the distance formula. So suppose I take a point on my graph. Let's take this point here and say that's some point x comma y. Okay? By the definition of parabolas, we know that the distance from this point to the focus should be the same as the distance from that point to the directrix. Okay, and once again, the directrix is this line. Now, what we want to be able to find is where this A comes from, and it actually comes from a distance formula. Notice that if I draw in a triangle here, if I drop a perpendicular down, I'll have a small little right triangle up above, right? If I want to know what the distance of this hypotenuse is, right, so I'll mark that with an H. I want to know what the distance is from this point to the focus. I can use the Pythagorean theorem. Okay, I know my longer side here is going to be x, right? I've gone x distance from the origin, so I've gone over x distance, and then this little sliver up above is going to be p's distance, right? Because the total distance is p, right? From the vertex to the focus is p's distance, but then I've gone up y. So this little sliver is actually going to be p minus y. Okay, so let me just kind of draw that triangle off to the side here. And I'm going to make it a little bit bigger so we can see things a little bit clearer. So the first thing to note is that on the x-coordinate, the triangle is starting at 0, and then the point goes to some x. So my width has to go to some x. So this whole length here on this side is going to be a distance of x. Okay. Then if I look at my diagram here, it's pretty small, but if I start at the origin and I go up to the focus, we remember from above that the distance from the vertex to the focus is always some p distance. Okay. So in this picture, from the vertex to the focus has to be some p distance, and then if I look at my point, I've gone from the origin or the vertex to some y. So I need to subtract those two to figure out what's left on this small little sliver on the left hand side of the triangle. So this side here is going to actually be p minus y. That's going to be the length of this side here. Now, to find h, we just use the Pythagorean theorem. So we know that if I take p minus y squared, and I add that to x minus 0 squared, and I take the square root of that, it has to be equal to the h. Okay? So this equation will give me h. Well, if I go back to the diagram for a second, I know that this side length, this h side length, has to be equal to this length as well. And so that means that this side length, if it's equal to h, this side length has to be equal to h as well. Well, on this one I can't really draw a triangle because it's already perpendicular, but I can still kind of think of it as a triangle. So for instance, I'm going to draw this one off to the left hand side here. So right now I just have this vertical line. It's going from the point that we drew, and it's going to the directrix line. Okay, so I'm drawing this little segment here. I'm just jotting it down over here. The first thing to note is that if I think about this as if it's a triangle, it's kind of a little weird to think about it as a triangle because it doesn't have three sides. But you can think of one of its sides is 0, right? It's like a triangle, right? So say I had a triangle, but then I kept moving this outer side in closer to this side until it just disappeared, right? I'm moving this side in until I have a vertical line. So I can actually think of this line as a triangle. It just has one of its side lengths as 0, right? There is no width to the triangle because it's just a vertical line. I then need to think about what's the length of its height, like how tall is this triangle, and to do that I can look back at my diagram over here. So just like before, I know the distance from the vertex to the directrix is some p distance, and then from the vertex up to my point I've gone up some y distance. So the length of this vertical line is going to be y plus p. So if I want to find the length of this line in terms of an equation, I once again can use a Pythagorean theorem. I can take one side squared plus the other side squared, and then if I square root the sum of those two, I'll get the length of the hypotenuse, which in this case is the same length as the line. So for instance, this would be equal to 0 squared plus y plus p squared, and then I'm taking the square root of both sides. Now, at this point it just becomes a simplifying problem, so I can clearly take the square of both sides. You'll notice that it'll cancel on both sides, so if I square both sides of the equation, the square and the square roots will cancel with each other, they'll go away. I'll be left with p minus y squared plus x minus 0 squared equals 0 squared plus y plus p squared. Okay, so I've gotten rid of the radical signs on both sides of the equation. Now I can go ahead and actually multiply out these squares, and I'm going to do it kind of the shortcut way. So if I take the square of a binomial, I can take p squared, the first term squared, so p squared, and then I take twice the product of these two. So p times a negative y is a negative py, but then I have to double it because there's really going to be two of them. So it's actually negative 2py, and then I square the last term. So negative y times negative y is a positive y squared. And then lastly, if I look at this one over here, well, x minus 0 is just really an x, and then x squared will be just x squared. And that's going to be equal to, if I look at the other side, 0 squared is just 0, so that'll really just go away. And so I just really need to, once again, square y plus p. And once again, I'm going to do the shortcut method. So anytime I square a binomial, I first square the first term. Well, y squared is just y squared. And then I take twice the product, so y times p, and then I want to double that, so I'm really going to get 2py. And then lastly, I square this last letter, so p squared on the end. Now I can look at simplifying this problem further. Notice that there is a p squared on the left-hand side and a p squared on the right-hand side, as well as a y squared on the right-hand side and a y squared on the left-hand side. So when I subtract my negative y squared and I subtract my negative p squared, you'll notice that it'll cancel on both sides. It'll completely be gotten rid of. So now I'm down to just having negative 2 py plus x squared equals 2 py on the other side. Now at this point, I can subtract negative 2 py from both sides. Okay? You'll notice that it'll give me 0 on the right hand side and negative 4 py plus x squared on the left hand side. Okay? At this point, I'm going to subtract my x squared. So I'm going to get rid of the x squared, move it to the other side. This is going to give me then, I'm kind of running out of room here, but I'll try to squeeze it in. Negative py equals negative x squared. And ultimately, I want to solve for the y. So I'm going to divide by negative 4p. So if I go ahead and divide by negative 4p, divide by negative 4p, okay? Notice that the negative 4p's on this side will all cancel. I'll be left with just the y. So I'm going to try and squeeze it over here to the right hand side. I get y equals, now anytime I divide a negative by a negative, the negatives go away. So those are really going to become positives. So I really get 1/4 p. Right, if I break this apart right now, there's actually a coefficient of 1 on the x squared term, so I get 1/4p, and then times x squared. Okay, so now if we look back up at what we were trying to show, we wanted to know where does this a equals 1/4p come from. Well, if you look at my equation, right now I have y equals 1/4p times x squared. And so you can see that this first part, this 1/4p, is the a in the equation y equals a times x squared. So where this a equals 1/4p is coming from is coming a little bit from the definition of what a point on a parabola is, and then it's using the Pythagorean theorem twice to show that every equation is going to have this relationship. The biggest thing that we need to remember moving forward is this equation that a equals 1/4p. This will be an important equation moving forward in this chapter.